Hello everyone. So today we are discussing about the halogenation of the alkenes. NCERT chapter class 12 haloalkanes and haloarenes. There is a section called the addition of the halogens on the page number 165. So today we are going to cover it by a mechanism point of view. So let's start our discussion. So what NCERT writes a reaction is something like that a molecule like CS3CS2 double bond sorry CS3CS double bond CS2 when it is treated with Br2 in the presence of carbon tetrachloride or carbon disulfide, it get converted into the something like that. Now, what is the mechanism of this chemical reaction? Probably you have some idea regarding the electrophilic addition reactions. And absolutely the same mechanism is here. And in an electrophilic addition reaction, the reactivity of the halogens in an order, that is fluorine is highly reactive, then chlorine, then bromine, then iodine. Iodine in fact give the reversible reactions, and fluorine is highly explosive in reaction, so we not use that fluorine. So what is the mechanism? So if I ask you that halogens are actually electrophile, your answer would be yes, because of availability of the anti-bonding molecular orbitals. And that is an absolutely reason for the halogens electrophilicity. Okay. So if I ask you there is a negative body and I bring a uncharged body, would there be an induction of the charges takes place? Your answer would be yes. The same thing takes place here. If there is a negative charge, because this alkene is nucleophile and it only react with an electrophile. So when Br2 molecule approaches here, there is an induction of the charges takes place. Induction of the charges takes place that leads to polarization of the bond between the bromine and bromine. So there is a partial negative charge and partial positive charge develop due to the nucleophilic effect of this alkene. Now this bromine is electrodeficient and this is a nucleophile. It will share its electron, that is the pi electrons, with bromine, and the resultant structure formed would be something like this: CS3CH. Now this bond is cleavage and bond formation is taking place between this bromine, and this bond is break because this electron is shared in the anti-bonding molecular orbital of this bromine. So this electron is free and it is free as Br minus. But at a simultaneous effect, there is a carbocation formed here. So bromine will share its lone pair to this carbon. It results in the formation of this CS3, CH, CS2, Br plus. This is the cyclic halonium or brominium ion. Cyclic brominium ion. This is also non-classical carbocation. It is only formed when electrophile is carrying the lone pair. So it is a cyclic brominium ion and non-classical carbocation. It does not rearrange. Do not rearrange. Okay. Now this is an highly unstable. Why it is highly unstable? Due to the angle strain. There is an angle strain. Three-membered cyclic rings are full of angle strain, so they are the unstable one. Now what will happen? This bond cleavage will take place and resultant thing form here is CS3CH, CS2 and this Br along with this carbocation. Now Br minus is there. Br minus approaches this carbocation, and when this carbocation approaches this, the addition product would be this. And this is your final product. And that is the mechanism of this chemical reaction. So note it down. An important thing is to understand that this carbocation actually not formed here. It's just an intermediate of this reaction. uh, Immediately this bromine get bonded with that because it has a lone pair, and lone pair is easily get into the back bonding. Another thing is important is that alkyl iodides not prepared, as we had mentioned, they give the reversible reactions, and fluorides also because they are highly reactive and highly explosive in nature. NCC or the non-cyclic carbocation or ring is opened from that side from which the carbocation is more stable. Like the carbocation 2 degree formed here, that's why we had opened this NCC from this second 2 degree carbocation, not from 1 degree carbocation, because 1 degree carbocations are less stable. So that is all about the mechanism of this. Thank you.